Hello everyone. I hope you all are good. So, in this station, what I'm going to do is to discuss AIT 5 NEET questions for class 12. So, I have picked some important questions. Even after that, if you feel like you're left with some more doubts, you can ask me in the live class. Okay. So, let's start with first question. Uniform electric field of magnitude. So, magnitude of electric field is given, that is 100 volt per meter. Okay. And this electric field is directed along the line y equal to 3 plus x. So if you're going to draw this line, y is equal to 3 plus x, its slope is positive. Its slope is what? Positive. And its intercept is what? That is also positive. So this graph will look like what? If we draw it, it will look something like this. Then its slope is positive and its intercept is also positive. And this slope value will be how much? Y is equal to x plus 3. So if we put it in form of y equal to mx plus c, m value is 1. That is slope is 1, tan theta is 1. So theta is how much? 45 degree. Sorry, 45 degree. So this is 45. So this will also become how much? 45. And magnitude of electric field is given, it is this. So this electric field can be written in terms of I cap and J cap. So E cos 40, electric field in vectorial form can be written as E cos 45 plus E sin 45. Done. And for this direction is I cap and for this direction is J cap. So if we go on to write it, it will become 100 into 1 by root 2. That is 50 root 2 I cap plus 50 root 2 J cap. Done. This is. Now find the potential difference between point this and this. So we are given 2 points, 3, 1 and B, 1, 3. Done. And we have to calculate potential difference. What is the formula for potential difference calculation if electric field relation is known? So there is one relation, dV is equal to minus E dot dl. Minus E dot dl. So if you look at here, potential difference between point A31 and B13. So let's plot these 2 points and let's see how we can use this. So let's write dl vector also because we have written E vector and here there is E vector. If you know dl vector, we can use the formula. So dl vector can be written as what? Points are given 3, 1, 1, 3. So dx I cap plus dy j cap. Dx will be equal to 3 minus 1, that is 2 I cap. And dy can be written as 1 minus 3 minus 2 j cap. Now let's use the formula. So minus E 50 root 2 I cap plus j cap dot 2 I cap minus 2 j cap. If you go on to calculate the dot product, I cap dot I cap is 1. So this is 100 root 2 with minus sign. And I cap dot j cap will be 0. J cap dot I cap will be 0. And then dot j dot j will be what? That will be 1. So if you calculate it here, it will become how much? It will become plus 100 root 2. So this is equal to 0. So potential difference is going to be what? It is going to be dV is going to be equal to 0. Now let's look at this question. 3-point charges plus q minus 2q and plus q are placed at point x equal to 0. So x equal to 0, y equal to a. So one charge is kept here, that is plus q. Okay. And minus 2q is kept at origin. So here there is a charge minus 2q. And then plus q is kept at x equal to, x equal to a, y equal to 0, x equal to a. That is here, again plus q. Okay? This is given. The resultant magnitude and direction of electric dipole moment vector of this assembly are. So if you see here, minus 2q can be rearranged like minus q and minus q. So if we look at this plus q and minus q, dipole moment is in this direction. If we look at minus q and plus q, Here, dipole moment is in this direction. So we have two dipoles. One is this, another is this. Done it? So let's say this is P1, this is P2. P1 the magnitude will be equal to how much? Q into distance between them, that is A, QA. Similarly, P2 is also magnitude wise QA. Angle between these two is 90 degree. So net dipole moment will be addition of these two. So इसको क्या लिखोगे? √2QA. And I don't need to write the formula. It's a very simple thing. So this is this. So resultant dipole moment will be what? √2QA. Now let's deal with the direction. So if you are going to add P1 plus P2, so or P2 plus P1, both are commutative. Vector addition is commutative, so we can do either things. So if you're going to do that, what it will look like? Yes, tell me. So P2 plus P1. Suppose I'm going to do P2 plus P1. Yeah, P1 plus P2, whatever you do. If you do it, P2 plus P1, it will look something like this. P1 को मैं इधर लेकर गई. So this will look like what? P1 plus P2. So P1 plus P2 is along which direction? It is said it is along the line joining the points. ठीक है? So these were the points. These were the points. अगर अगर इसको ऐसे लाइन ज्वाइन करो तो क्या इस डायरेक्शन के अलोंग है? We need to see it क्योंकि हमने vector addition में we have already studied that that parallelogram law of addition. So if we make a parallelogram, then this will also give us the addition value. Diagonal gives us the addition value. So yes, direction of dipole is along line joining the given points. We can tell that. ठीक है? And it will make certain angle with the y-axis. So that angle will be same here also for this line also. So if I'm saying this is addition vector P1 plus P2 and I'm saying this is also P1 plus P2, I'm not making their direction different in terms of how much angle they are making with the y-axis and x-axis. That is still same. But we can quote it like this. I mean, these two options are not given. Root QA along the positive y direction? No. Root QA along line joining the given points? It seems like QA, no. That is, that magnitude is wrong. Root 2 QA along the x direction, wrong. So this seems correct. So B will be the correct option. Now, four equal charges Q are placed at four corners of a side of A each. So this is like this. And 4 plus Q charges are kept. Work done in removing a charge minus Q from its center to infinity. So there is a charge at minus Q and we have to remove it from here to infinity. So work done is equal to what? Charge getting removed, okay, into potential difference. So we need to calculate what is potential difference here and what is potential difference at infinity. That is 0 by convention. So it is 0. And here potential difference will be what? Here potential difference will be because of this charge, because of this charge, because of this, because of this. All are positive charges. So potential as V1 is 4 into potential due to any one of the charges because all are equivalent in terms of magnitude and distance from this point also. And this distance, whole distance is equal to how much? √2a. So half of this will be potential formula is kq by r. So r here is how much? That is √2a by 2. That is a by root. This is because of single charge. Because of four charges, it will be this. So 4√2 into q by k को अगर ब्रेक करोगे तो कितना होगा? 4 pi epsilon naught. Done है? So 4 will get cancelled and it will remain how much? √2q pi epsilon naught a. So work done will be equal to minus q into potential difference. Final potential difference is 0. Initial potential difference is √2q by pi epsilon naught a. So correct option will be how much? √2q. Q is capital Q, right? Done it? So this will be root 2 q ka square by pi epsilon naught a. So this is going to be our correct option. Now, if charge on the left plate of 5 microfarad capacitor in the circuit shown in the figure is minus 20 microcoulomb, charge on the right plate will be how much? Okay. So, left plate of 5 microfarad. This is the right plate and this is the left plate. So left plate is given how much charge? Minus 20 microcoulomb. So plus this next plate will have same positive charge. So here the charge is plus 20 microfarad. I have taught you concept of isolated system. If you see the diagram carefully, it looks something like this. It looks something like this. है ना? And if I can apply here that isolated system concept, yes. If you talk about these three plates, then these three plates are not directly connected to the battery, so their charge will remain conserved. It means before this system was connected with battery, charge on these three plates, sum of charge is zero, and finally also it should be zero. So finally, let's say this has a positive charge of plus q1 and this has a positive charge of plus q2. Then according to the question, q1 plus q2 and this will have a positive charge plus 20 will be equal to how much? Will be equal to 0. This is by law. Now let's see these two capacitors, 3 microfarad and 4 microfarad are in parallel. So they will have same potential difference. Let's see here potential is V and here also it is V. So Q1 can be written as 3V and Q2 can be written as 4V. So if we write here 7V equal to minus 20 and V will be equal to minus 20 by 7. We are asked charge on the right plate of 3 microfarad capacity. So V is this, Q1 is how much? Charge on the right plate of 3. So let's calculate Q1. Q1 is how much? 20 by 7 into 3. If we go on to calculate this, this will become 60 by 7. And if we calculate it, this with minus sign, minus 8.57. So this is Q1. And Q1 is what? Q1, I said, plus Q1 is charge uh, on the left plate of 3 microfarad. We are asked charge on the right plate of 3 microfarad. So if plus Q1 is coming as negative, it means like my assumption was wrong. Assumption that this plate is having positive charge. This plate is having negative charge of minus 8.57 coulomb. So this will have a positive charge of 8.57 microcoulomb. So correct option will be A. So yeah, correct option is your what? A. Now let's do another question. As shown in the figure, two identical capacitors are connected to a battery of V volt in parallel. Okay. So initially when they are connected, what will happen? This switch must be closed then. And if we talk about energies, or if we talk about potential, then this capacitor will have potential difference V, and this also will have potential difference V. So this will have a charge of CV, this will also have a charge of CV. Now, when capacitors are fully charged, their stored energy is U1. So their stored energy means energy stored on both the capacitors is given U1. So energy stored U1 will be equal to half CV square plus half CV square. So this is equal to CV square. Okay. Now, if the key K is opened, and now what we are doing, we are opening the key. So now we are opening it. What will happen then? Second capacitor will get disconnected from the battery. So second capacitor stays disconnected. And first one is still connected. And now what is happening? Dielectric of dielectric constant 3 is inserted in each capacitor. So this is also given dielectric constant of 3. And this is also given dielectric constant of 3. And now the energy is U2. So how we will calculate U2? This is the question. Okay. So what happens actually? if we talk about inserting dielectric in absence of battery, as is the case in capacitor 2, then what will happen here? Since this is an isolated system, charge will remain conserved. So final energy here, if I talk about, this will be q square by 2c formula we will be using. Why? Because q here will remain constant, c will change by k times. C always changes by k times after inserting the dielectric. So q is not going to change even after uh, like we disconnected it from the battery, then q was cv, so it will stay cv even after adding the dielectric. So q square means cv ka square, 2 into c, c will now become 3 into c, kc. Okay, so this is going to be c square v square by 6c, that is cv square by 6. So second one became how much? Cv square by 6. Now let's talk about energy stored on this capacitor. So here, since it is connected to the battery, charge will change after inserting dielectric because capacity is increasing. I have taught you in the classes. So here energy will be how much? If we use formula half CV square. So half C will change K times. Why I didn't use this formula? Because in first case, Q is also changing, C is also changing. That is why I've simply used this one, because here only C will change. 3 into C into V square. V will remain constant because it is connected to a battery of potential difference V. So here, how much it is coming? 3 CV square by 2. Now, if we add this 2, let's multiply it with 3. Then I will multiply and divide by 3. So this will become 10 CV square by 6. So ratio we have to calculate U1 by U2. So CV square by 10 CV square into 6. So this will become how much? 3 by 5. So correct option will be A. Okay? Chalo. Now let's understand this question. Consider two concentric and middle spheres. The outer sphere is given a charge Q greater than 0. Then, okay? So just imagine one thing. There is a sphere inside and there is a sphere outside. So if this is, and these two are metal sphere, if this is given plus Q charge, then what will happen? Electric field will get generated like this, and this electric field will not penetrate inside the sphere because this is a metal boundary. Okay, so no electric field will escape to the inside, and that is why this sphere will not get polarized. And now we have studied electrostatic shielding. So that thing will happen, but here the case is different. It is connected to earth. Earth क्या होता है? Conductor है, so it can transfer charge to this. Okay. Now let's see. The inner sphere, what will happen over here? First option, the inner sphere will be polarized due to the field of the charge Q. No, it cannot happen. The electron will flow from inner sphere to the earth. Now let's check that. Once we have connected it to the earth, potential of this sphere will become 0. And we have given a charge plus Q on this sphere. Let's say here the charge is small q. This charge is not because of polarization, because it may have, yeah, this much charge is because something has happened after making connection with the earth, so that potential of inner sphere is maintained at 0. So if we calculate potential of inside a sphere, potential of inside a sphere because of charge on the outside sphere will be kq by a, and because of charge on itself it will be kq by a, and this should be, sorry, and this would be 0. So if we talk about this, kq by b equal to minus kq by a, k will get cancelled. So small q value is how much? This is equal to minus bq by a. So it is said here the electron will flow from inner sphere to the earth. No. Agar inner sphere se electron flow karta hai, it will gain positive charge. But here we are getting negative charge. So this is also false. The sorting of S will produce a plus charge of this one, negative charge of this one, or charge of this one on the inner sphere. Yes, correct. Okay. So correct option is what? C. Now, N identical cell, each of EMF E. So we have N identical cell, each of EMF E. And what is happening? Each has an internal resistance of R. And they are connected in series to form a closed circuit. And then closed circuit is formed like this. Okay? N cells are here. And one cell is joined with reverse polarity. So one cell is joined with reverse polarity. Potential difference across each cell. So I have taught you when n, suppose there are n cell connected in series like this, and m cell are connected in reverse polarity, then actual EMF of the whole circuit for this case, I mean, I'm telling you, if there are n cells connected in series forming single closed loop, and within that n number of cell, m number of cells are connected wrongly, then or in a wrong way, then net EMF of the loop will be how much? E net will be Ne minus 2Me. Always remember. Okay? So here n into E minus m value is how much? 1. So 2E. So net EMF is going to be how much? E n minus 2. Now, what will be the R equivalent of the circuit? So, R equivalent will be sum of all the small internal resistances connected in series, NR. So, what will be current in the circuit? Current in the circuit is going to be this much. Okay? Now, potential difference across each cell. If I talk about single cell, then potential difference is written as what? E minus IR. So, E minus I is E n minus 2 by NR. This one. So if you go on to calculate this, this will become Ne minus Ne plus 2 by how much? EMF? E, 2E, I need to write here. 2E divided by how much? N. So answer is how much? It is 2E divided by N. So correct option will be A. Okay? Now let's move ahead. For what value of R in the circuit as shown in figure, current passing through 4 ohm resistance will be 0. So current passing through this is 0. If there is no potential difference across this, sorry, there is no current flowing through 4 ohm, it means potential difference between these two is what? 0. So if here this is plus 6 volts, say, suppose, then here it will also be plus 6 volt. Okay? If I am giving it 0 volt wala thing. So potential of this point I am making at 0, suppose. Then potential of this point from the battery thing will become plus 6. So this will also become plus 6. Now, if this point is 0, then potential of point A will become plus 9. And if potential of this is taken as 0, then potential of this will become minus, because potential difference has to be 3. Done it? So potential of D is plus 6, and here it is plus 6. So I have done the distribution of potential. Current passing through 4 ohm resistance will be 0. Then for what value of R in the circuit? R का value निकालना है, for which current flowing through 4 ohm is 0. So what will be the value of R? Just see here. If there is no current going through 4 ohm, it means suppose 9 volt is driving the current in the circuit. So now from 9 volt current will come like this, and it won't go to the 4 ohm. So whole current will go here. So this is a single loop circuit now because no current is flowing through 4 ohm. And if we calculate current in this branch, then potential difference is plus 9 minus 6, and that is 3 volt. So current will be equal to how much? 3 by 2 ampere. And here also current will be what? 3 by 2 ampere, same current is going. And if we calculate current over here, this is plus 6 volt, this is minus 3. Potential difference here in DE arm is potential difference. कितना दिख रहा है? 9 volt. Current will be, I will be 9 by R, and this is equal to 3 by 2. So if we go on to calculate this, R will become how much? 6 ohm. So correct answer will be your 6 ohm. ठीक है? चलो. Now let's do this question. 2 cities are 150 kilometer apart. So two cities are there and they are 150 kilometer apart. Electric power is sent from one city to another city through copper wires. The fall of potential per kilometer is 8 volt. So per kilometer fall of potential is 8 volt. So total potential drop, if I talk about for 150 kilometer, this is this one. है ना? And average resistance per kilometer 0.5 ohms. So total resistance for 150 kilometer 150 into 0.5. So power loss in the circuit, power loss is written in V square by R. We can write it. So V square is 150 into 8 ka square divided by R, that is 150 into 0.5. So this will become 150 into 64 divided by 5 into 10. Okay, so this will become how much? This will become 30, and if we multiply it, this will become 19200 watt. So in terms of kilowatt, if we write, it will become, sorry, 19.2 kilowatt. Okay, so this is going to be our answer. Correct option is B. Now, in the hydrogen atom, electron is making 6.6 into 10 to the power 15 rotation per minute. If the radius of orbit is this much meter, then magnetic field produced at the center of orbit. So let's say this is the orbit and radius of the orbit is R. Current flowing through this is I because of charge going in the circle. Then so magnetic field at the center will be mu naught I by 2R. Simple. Okay. So what is going to be I ka value? Here you see, if we know electron is going round and round, so current can be written as like this is making one chakkar, that is one revolution in one time period. It means current is what? Charge flowing in that in amount of charge flowing in a particular interval of time. So for time period T, how much charge is flowing? E. So this will be current. And here's like how many rotation? It is making 6.6 into 10 to the power 15 rotation in 1 second. So one rotation it will make in how many? It will make in how many time? 1 by 6.6 into 10 to the power 15. Yani कि this is going to be the time period. Okay. So what will be the current? So if you calculate current over here, current is E, that is, let's say E divided by time period. So that is equal to 1 divided by 6.6 into 10 to the power 15. So basically E into velocity given here. Here velocity is given in rotation per second. That is why I have used this here. If velocity is given like V, so like टी टी क्या होता है? टी को जैसे मैं फॉर्मूला बता रही हूँ बस. टी इक्वल टू 2 पाई बाई ओमेगा यू, राइट? एंड इफ वेलोसिटी इज गिवन इन टर्म्स ऑफ वी, देन यहाँ पे मल्टीप्लाई कर दो आर से. सो ई ओमेगा आर, सो दिस विल बिकम ई वी बाई 2 पाई. But here we don't need to do this much because from here only we can calculate time period. It will be 1 by this will give us time period. So E by T, simply put it there. So यहाँ पे अगर मैं put करूँगी mu naught into E into velocity given here divided by 2R. Now put the value here. Rotation per second it is given. If it was given as rotation per minute, you require to change it into second. Okay, but here it is given in second. Radius is also given. Now put the value, you will get the answer. So correct answer will come which one? It will be, sorry, not this one. It will be this one. Okay, so I hope you will calculate it. Just you need to do the calculation. A circular coil ABCD carrying a current I is placed in a uniform magnetic field. Magnetic force on segment AB is given. On AB, what force is acting? Suppose the direction is this, F dash force is acting. So the force on remaining section BCDA will be what? I have told you, if any closed loop, current carrying closed loop, it is kept in a magnetic field which is uniform, then net force acting on the closed loop will be what? Zero. I have told you this one. And here the magnetic field is uniform and this is a closed loop carrying current. Net force has to be zero. Yani ki force on section AB plus force on section BCDA has to be zero. So force on AB is F plus F BCDA equal to 0. So force acting on BCDA will be equal to how much? Minus F. So correct answer will be B. Now, a 10-meter long copper wire remaining in the east-west direction. So that is in east-west direction. इस direction में है, and this is falling down with a speed of 5 meter per second. It is falling down with a speed of 5 meter per second. If perpendicular magnetic field to the wire is this much, then EMF developed between the ends of the wire. So I have taught you EMF developed formula is BVL, and this formula is when velocity is perpendicular to the length. When velocity is not perpendicular to the length, in that case, suppose here velocity is like this, then we will take the component of velocity which is perpendicular to the length. And also second check I have said you to do, that is magnetic field and plane of rod in which it is moving should be perpendicular to each other. So see here, it is falling down. So falling down means it is in vertical plane and magnetic field perpendicular to the wire. So magnetic field is not perpendicular here given, it is perpendicular to the wire. So it must be perpendicular to the plane, then only it is asking EMF induced across its end. तो वी डोंट नीड टू डू फर्दर चेक्स बिकॉज यहाँ पे होगा या नहीं होगा का ऑप्शन नहीं है, बिकॉज 0 volt इज नॉट गिवन इन द ऑप्शन. So it is perpendicular to the plane of fall of rod. So put the value of B, 0.3 into 10 to the power minus 4. Put the value of velocity. ठीक है. So nothing is getting talked about gravitational force. So we have to neglect it here. It is said that it is moving down with a velocity of 5 meter per second. So it is moving constantly with this. Let's put the value. And length given is how much? That is 10 meter. If you're going to solve it, this will become this. So 15 into 10 to the power minus 4, that is 1.5 millivolt. Done. So correct option will be D. Now, a physicist works in a laboratory where the magnetic field is 2 Tesla. She wears a necklace enclosing area. So area of the necklace is given 0.01 meters square in such a way that the plane of necklace is normal to the field and is having a resistance 0.01 ohm. Because of power failure, the field decays from how much? From 2 Tesla to 1 Tesla in 10 to the power minus 3 seconds. Then what is the heat produced in the necklace? So heat produced will be equal to how much? I square RT. So we need to calculate I. R is given, time is given. So I will be what? EMF induced by R. है ना? And if we talk about EMF induced by R, then we can first we need to calculate EMF induced. और EMF induced क्या होता है बताओ? EMF induced will be change in flux in change happening in particular interval of time. Negative sign for Lenge's law. So magnitude, if I'm calculating, I will neglect the negative sign. Delta phi is how much? It is 1 minus 2. That is magnitude wise 1. Delta phi will be equal to B into B dot A होता है ना flux. So initial flux is how much? Initial flux will be 2 Tesla into area 0.01 meter square. Final flux 1 Tesla into 0.01 मीटर का स्क्वायर. देखो B dot A करोगे तो BA क्या होता है? Cos theta. And here it is said that plane of necklace is normal to the field. यानी कि plane of necklace अगर normal to the field है, then area vector is normal to the plane. यानी कि normal to the plane is area vector and magnetic field is also what? Just try to make sense of this, what is given. Plane of the necklace is normal to the field. So if this is the plane, so normal to this field plane will be this much, this. So in this direction is magnetic field. Also area vector will be normal to the plane. So both are sharing the same direction. So theta is 0. डन है। सो फ्लक्स चेंज अगर मैं निकालूं तो 0.01 इंटू 1 होगा, है ना, 2 - 1। मैग्नेटिक फील्ड इज चेंजिंग, एरिया इज रिमेनिंग कांस्टेंट, एंड दैट इज हाउ फ्लक्स इज चेंजिंग, डिवाइडेड बाय डेल्टा टी, दैट इज 10⁻⁻3। So EMF getting induced is how much? It is 10⁻⁻5 volt. Sorry. So if you put here I square को क्या लिख सकते हैं? E square by R square. So basically this is E square by R into T. Now let's put the value. E square will be 10⁻⁻10 by R is how much? R is your 10⁻⁻2. T is your how much? 10⁻⁻3. So this is how, okay, here I have calculated EMF as incorrect. गलत mathematically solve किया मैंने. This is 10⁻⁻2 by 10⁻⁻3. So this is equal to how much? 10. EMF induced is 10. So let's remove it. This is E square means 10 ka square, 100. So this is going to be equal to how much? 10 Joule. So correct answer will be which one? It will be A. Correct answer is going to be your A. ठीक है. Calculation should be done properly. अब चलो देखते हैं. The figure shows 4 wire loops with each length of either L or 2L. ठीक है. All 4 loops will move through a region of uniform magnetic field given over here at the same constant velocity. Rank the 4 loops according to maximum magnitude of EMF induced as they move through the field. So if I talk about first loop, then first loop getting entered is this one. If this will enter into the field, then it will look like this. So this is one length, it is moving with velocity v. It is moving with velocity v. This end is also moving with velocity v, and this one is also moving with velocity v. Induced EMF के लिए I have told you velocity should be perpendicular to the length. So if I talk about this portion, no EMF induced because of these two lengths, because velocity is parallel to the length. If you talk about these two lengths, according to maximum magnitude as they move through the field. Actually, it is asked about as they are moving through the field. So, but I have completely kept this one inside. So this is a wrong explanation. क्योंकि उसको completely inside नहीं रखना है. As they are moving into the field, then we have to explain. So let's draw the diagram again. Explanation will be same. Suppose half of the portion is inside. Again, diagram is not looking like first one. Sorry. So here, if we do, still it is entering into this magnetic field region. So this, there cannot be EMF induced because of this length, because of this length. This length is outside magnetic field, so B0, no EMF induced, but this side is inside magnetic field, moving with velocity perpendicular to the length, and also magnetic field is perpendicular to the plane of motion of the loop. So here EMF induced will be only across end AB, and this will be equal to BV, this length. So this length is 12. Done. Similarly for this, if you see, अगर ये अंदर जाने लगेगा, then only this, because of this end there will be EMF induced, same BV12. So for EMF induced will be same for loop D and loop C. Now, if you talk about loop B, then as B will enter, it will look something like this. So this length is perpendicular. यानी कि EMF induced in B loop will be equal to BVL, and similarly in A it will be BVL. ठीक है? So EC ED is greater than EA and EB, and EA and EB are equal, EC and ED are equal. So correct option is. Now, a series LCR circuit is connected to a AC voltage source. When L is removed from the circuit, the phase difference between current and voltage is this. So phase difference, if we talk about, phi is written as tan inverse XC minus XL by R. We have already done this. Okay. So when L is removed from the circuit, there is LCR circuit. It means there is R, there is L, and there is C. So this is a LCR circuit. And when L is removed from the circuit, phase difference between current and voltage is pi by 4. Okay. So if XL we are making 0, in that case, phi is becoming 45 degrees. So tan 45 is equal to XC by R. So this will become 1 is equal to XC by R. This is happening. Done. If instead L and L, C is removed from the circuit, phase difference between current and voltage is still pi by 4. Yani ki, if we are making now XC equal to 0, then also magnitude wise, angle is 45 degree. It means again magnitude wise, XL by R is equal to what? 1. So XC is equal to R, XL is equal to R. It means XC is equal to XL. Done? So the phase difference, the power factor of the original circuit. So original circuit means circuit in which there is R, there is L, there is C. So power factor will be tan inverse XC minus XL by R. And XC and XL are equal. So this will become how much? This will become 0. Done hai? So tan phi is 0. It means, sorry, power factor, tan phi is 0, so phi is equal to 0. Power factor is what? Power factor is cos phi. So cos phi will become how much? Cos phi will be 1 because cos 0 is 1. We needed to calculate power factor. Power factor is cos phi. So we calculated phi from here and then we calculated cos phi. Okay? So correct option will be which one? C. Now, the value of alternating EMF in the given circuit will be alternating EMF. How we calculate net EMF in LCR circuit or in AC circuit? Vectorial method से calculate करते हैं. So here VR is given, VC is given, VL is given. I have told you, always draw the diagram like this, right angle triangle. VC minus VL you write along this line, or VL minus VC magnitude wise. And here R, add them. So here VC is 100 volt, VL is 40 volt. So this will become 60 volt and this will be our 80 volt. So 60 volt and 80 volt vectorially if we will add at 90 degree, this will become 60 ka square plus 80 ka square. So this is 3600 plus 6400. So this is basically 100 because 64 plus 36 will be 100. So 100 into 100 outside 100. Now, the RMS value of alternating voltage given by an equation, this is RMS value we are asked. So, time and again, I have told you, if voltage is given as a sum of sine and cos, try to reduce them into one. So, for that, formula to use कर ही सकते हो sin cos का, जैसे sin A cos B plus cos A sin B, like that. But easy way to do is make a right angle triangle. Take one digit, one coefficient of sine or cos as the base. So I'm taking 8 as the base and 4 as a height. Now what you do? Now you do one thing. Take this angle, suppose this is phi, and hypotenuse will be equal to how much? 64 plus 36. So, no, 64 plus 16. So this will become 80 root under. So this will be how much? This is your 4 root 5. Done it? Now, whatever hypotenuse you are getting, divide that with, multiply this hypotenuse here and also keep that in division. Okay? So E is equal to how much? 8 sin omega t है minus 4 cos omega t. What I am saying is कि जो भी hypotenuse आया है उसको multiply कर लो. So you need to divide also. Now, 4 root 5 you take outside and this one you take inside. So 8 by 4 root 5 sin omega t minus 4 by 4 root 5 cos omega t. If you look here carefully, 8 by 4 root 5 is what? Cos 5. So this is what? This is your cos 5 sin omega t minus sin 5 cos omega t. This is this. Right? If you do further, 4 root 5 This is what? This is sine omega t minus pi. So this way we are getting the amplitude of the what? EMF. Done. So RMS value will be if voltage is given as V naught sine omega t plus phi or minus phi, then VRMS we have already calculated for such sort of voltage equation V naught by root 2. So here VRMS will be V naught by root 2. So VRMS को अगर लिखोगे 4 root 5 divided by 2, root 2. ठीक है? So if I multiply here with root 2 like this will become 2 root 10 volt. So correct option will be C. Now let's read this question. A converging beam of rays is incident on a diverging lens. So there is a diverging lens, it means concave lens. And what is happening? Converging beam of ray is incident. So if you are drawing the ray is coming like this, ray is coming like this. So if we see incident, where incident rays meet, that gives us object, right? Here, object is not specified, but incident rays are converging, but they are not actually meeting before it is falling on the lens. So we will see where it will appear to meet. So here, so where incident light appear to meet, that will give you virtual object. So here, this is virtual object. So this is virtual object, okay? Having passed through the lens, the sorry, the rays intersect at a point 15 centimeter from lens on the opposite side. And when these rays are passing through the lens, where they are intersecting actually on the left hand side of the lens. So let's see, let's say this is the optic, this is the axis. So actually they are meeting, they will get refracted. So suppose यहाँ कहीं meet किया, ठीक है, यहाँ. And this distance is given as what? 15 centimeter. So object distance is, image distance is given here, 15 centimeter. Object distance is not given. Let's see. Now, if the lens is removed, the point where the rays meet, if lens is removed and then where these rays are meeting is 5 centimeter closer to the lens, it means it will meet somewhere here. Then 5 centimeter closer means 10 centimeter. So without lens, where the rays are meeting, that is the object position basically. And with lens where the rays are meeting, that is image position. So object distance is how much? 10 centimeter. Now use uh, lens formula to calculate focal length. So 1 by f equal to 1 by v minus 1 by u. Use sign convention properly over here. Image is in this direction, measured. Object will get measured also in this direction, both positive, right? So if we write here 1 by v, that is 1 by 15 minus 1 by 10. Done. So do one thing, 3 से multiply कर दो, इसको 2 से कर दो. So this will become minus 1 by 30. यानी कि focal length is minus 30 centimeter. यानी कि answer will be D. So there was a concept of virtual object. Okay. Now let's do this question. There is something drawn already. Let me remove it. We'll get back to you. So let's look at the question, read the question. What should be the value of theta so that light entering normally to the surface AC of a prism does not cross second refracting surface? So if it is coming here like this, draw the normal over here. If it is not able to cross AB, it means total internal reflection is happening at this point O. And for that, this angle should be at least minimum equal to critical angle. In that case, it will graze the surface. Okay? So let's say here it is, I see this angle. And this angle can be written in terms of theta. If this is theta, this is 90. This angle will be 90 minus theta. And this is again 90. And this angle from this smaller triangle will again become how much? Theta. And if this is theta, this is normal to AB. This whole is 90 degree. If this is theta, this is 90 minus theta. So if we apply at O Snell's law, then refractive index of the lens, sorry, of the prism into sine 90 minus theta will be equal to refractive index of air into sine 90 minimum. Done it? So here cos theta is equal to 1 by mu. So theta should be equal to cos inverse 1 by mu. So correct option will be A. In Young's double slit experiment, nth red bright band coincide with n plus 1th blue bright band. So if they are coinciding, what does it mean? They are getting formed at the same point. So let's say they are getting formed at this point. So for red light, if this angle is theta, then for blue light also it is coming like this. And this angle is theta. But for red light, it is nth bright band, and for blue light, it is n plus 1th bright band. Done it? So according to, if here maxima is getting formed, then d sine theta should be equal to n lambda. Done hai? So if we talk about red light, then for red light, this d sine theta, that is path difference, will be equal to n lambda. And for blue light, this path difference will be n plus 1 uh, uh, lambda blue light ka. Then, and these two should be equal because they are getting formed at the same point. So these two path differences are same, right? They are getting overlapped now. So here you will write n lambda r is equal to n plus 1 lambda p. Okay? So n into lambda r, if you put, red light ka wavelength is 7500, n plus 1, blue light wavelength is 5000 angstrom. So two zeros will get cancelled, and 10 से 5 times में this is 15 से 3 से 5 times में this is 2. Done. So 3n is equal to 2n plus 2. So this is n is equal to 2. So correct answer will be B. So whenever it is said that one is coinciding with another, it means their part differences are same, right? Now, a single slit of width A is illuminated by monochromatic light of wavelength 600 millimeter is given in the question, but answers are given according to 600 nanometer. The value of, so there was a mistake. The value of A for which first minima appears at this on the screen. So it is talking about single slit thing. So this is a diffraction, single slit diffraction, right? And for that, minima condition is what? For that, minima condition is path difference should be equal to n lambda, right? The value of A for which first minima appears at 30 degree. Delta x को हमने क्या लिखा था? A sin theta के फॉर्म में. जैसे interference में we are writing as d sin theta, where d was distance between two slits, and here A is the slit width because there is single slit, right? So A sin theta is equal to n lambda. The value of A we have to calculate, for which first minima appears at 30 degree. So A into sine 30 half, and for first minima n will be 1. So lambda A is equal to 2 lambda, and okay, so this is going to be how much? 2 into 6 into 100 into 10 to the power minus 9. So this is 12 into 10 to the power minus 7. So this can be written as 1.2 micrometer. So answer will be B. But since question here it was written as millimeter, you may have failed to get the answer. Really sorry for that. Now, if the momentum of electron is changed by P, then the de Broglie wavelength associated with it changes by this, the initial momentum of the electron. So let's say initial momentum is Pi, then de Broglie wavelength can be written as H by Pi. If it take change on the both sides, so delta lambda will be equal to H delta Pi ka power minus 1. Done it? So if we are going to do the things, dpi minus 1 by dp into dp. This we can do. So this will become minus h by pi ka square into dpi. That is change. So change, here it is given if momentum of electron is changed by p. So let's say dpi is equal to p. Then de Broglie wavelength associated with it changes by this percent. So here if सबसे पहले मैंने dpi को p लिख दिया. Now let's see. delta P is equal to माइनस एच बाई पी आई को यहाँ पे क्या लिख सकते हैं, लैम्डा आई लिख सकते हैं. सो एच बाई पी आई को आई एम गोइंग टू राइट हियर लैम्डा आई एंड देन स्टिल वन पी आई इज लेफ्ट and this is delta P, that is P given in the question. So, sorry, this is delta lambda. So, delta lambda divided by lambda I is equal to how much? This is P by P initial. So, P initial we need to calculate. This is given in our question. If delta P is P, then wavelength is getting changed by 0.4%. It means delta lambda by lambda into 100 is equal to 4 into 10 to the power minus 1. So delta lambda by lambda will be equal to 4 into 10 to the power minus 3. So let's write here. This is equal to 10 to the power minus 3 into 4 is equal to P by Pi. So Pi is equal to how much? This is equal to P into 10 to the power 3 divided by 4. So if you go on to solve it, this will become how much? 250 P. So nothing we were required to do, just we needed to do calculation properly. That was required. Now let's solve it. The work function for two metals P and Q are phi 1 and phi 2 respectively, with phi 1 greater than phi 2. So work function of P is greater than that of Q. Done. And how we calculate work function in terms of threshold frequency? So work function is basically the minimum amount of energy of light that is required to knock out the electron. So phi is written as h mu, where mu is threshold frequency, right? The graph between stopping potential and frequency of incident radiation then will look like. So stopping potential means kinetic energy maximum is written as energy falling on the surface minus work function. Done. This is the maximum kinetic energy. And in terms of stopping potential, Kmax is written as EV naught. And this is, or EV लिखो, HF minus phi. Okay. So V stopping potential is H by E F minus phi. Done hai? Now, one thing is here, there are two different sort of metals, P and Q. Their work function is different, right? So if you look at, if you draw the graph of potential versus frequency, stopping potential versus frequency, slope will be equal to H by E, done, which is your constant basically. So slope will be equal for both the metals, done. So this cannot be the option, this cannot be the option, because here slopes are shown different. Now slope will be equal. We have to finalize between A and B. Now let's check phi wala thing. So if you look at the graph equation carefully, here v equal to, यहाँ पे भी e का term आएगा. Done. So here slope will be negative. Sorry, slope is h by b. I'm talking about y-intercept. So y-intercept will be negative phi by e. And if we look at the graph one, or if we draw the general graph, then b versus frequency ka, then graph will look like this. And this will be the y-intercept. Okay? And this will give you what? This will give you what? Stopping potential. Sorry, this will give you phi by E. Done. And this y-intercept will be bigger if phi is more. Done. And here phi 1 is greater than phi 2. So P ka y-intercept will be more. And if we see here, if we will extend here and we will extend this. So y-intercept of P is less than that of Q. But if we extend here, and you will see this is this. So y-intercept of P is greater. So correct answer will be B. Also from another thing you can check, if F is a threshold frequency, then see here, if you talk about this point. So at this point, we can see that what? Frequency value is something and a stopping potential is 0. Stopping potential will be 0 when? When work function value is equal to the energy of light falling. In that case, F will become threshold frequency. So here, this point is basically threshold frequency getting shown. Threshold frequency of P is greater than that of Q because P ka work function is greater. So otherwise also just by looking at the graph, you can say if you have proper knowledge of that topic, threshold frequency of P is greater than that of Q in the second graph. And that is why second is correct. In the first, threshold frequency P का कम दिख रहा है, but according to question, phi 1 is greater than phi 2. So it has to be greater, not smaller. Now, the electron in the hydrogen atom jumps from excited state n equal to 3 to its ground state n equal to 1, and the photons thus emitted irradiate a photosensitive material. Irradiate a photosensitive material. What is happening? Let's draw the ground state first. Then there is this n equal to 2, and then there is this n equal to 3. There is one electron here, and it is jumping to this. When it will jump, it will release energy, and this energy is allowed to fall on a photosensitive material. That is happening in the question. If the work function of the material is this, the stopping potential is estimated to be. So K max को हम कैसे निकालेंगे? Energy of light falling minus work function. So what is the energy of light falling? So energy in the third state minus energy in the first state. So sorry, final state minus initial state. So कितना energy होगा बताओ? थर्ड का एनर्जी कितना होगा? -13.6/9, एंड इसकी एनर्जी कितनी होगी? -13.6. So it is jumping from higher energy to lower because with negative sign it is given. Done it? So magnitude wise this is less, but with negative sign it is, right? So this is higher energy than this is, because this is more negative, this is less negative. So it is jumping from lower energy state to higher energy state to lower. So it will release energy, and that energy value is how much? It is -13.6. Sorry, हाई को लो से माइनस करोगे ना? आई एम रियली सॉरी. So if you're going to do that, -13.6/9 किसके बराबर होगा? 1 point, if you see here 1.5 के नियर अबाउट होगा, है ना? डन है? 1.5 के नियर अबाउट. सो -1.5 plus 13.6 minus 5, that is 5.1. So if you're going to solve this, it will become 12.1 something minus 5.1. So this will become how much? 7 electron volt energy. So K max is written as EV, where K max, if we are writing in terms of electron volt, it will be E into stopping potential. So this is 7 electron volt. So let's say stopping potential is V naught. So V naught value is how much? 7 volt. E will get cancelled. So this is 7 volt. Answer will be C. Now, given below are two statements. One is labeled as assertion A, and the other is labeled as region R. Assertion: the binding energy per nucleon is practically independent of atomic number for nuclei of mass number in the range of 170. If you have seen the diagram carefully, it looks something like this. After that, it starts decreasing. So in this region, what is happening? Binding energy is almost constant. And why does it happen? Because in this region, the atomic mass has increased to such a level that nuclear force has saturated. Nuclear force saturated means, see, first assertion is correct. Done in this region between 30 to 170, binding energy is practically independent of atomic number because it's almost seeming constant. So it is looking constant means independent of all the factors. Now reason: nuclear force is short ranged. Yes. Why it is happening? Because as the mass is increasing, size of atom is increasing, but nuclear force operate in to certain extent. I mean, nuclear force operates only up to certain femtometer. So whatever nucleons are within this region, nuclear force is operating. If nucleons are present outside this region, nuclear force is not operating. It means what? It means even if you are adding more mass, that is, if you are increasing more nucleons, that is not contributing to more positive or more attractive nuclear force acting. It means force has saturated. And why binding energy is getting released? Because more because attractive nuclear force is acting, and because of that energy is getting released. If force is saturated, binding energy will get saturated. So nuclear force is short range. Yes, that is the reason. In the light of above statement, choose the correct answer from the option below. So both A and R are correct. And R is correct explanation of A. So D will be correct. From the same person, this question is given. The above is a plot of binding energy per nucleon AB against the nuclear mass M. A, B, C, D, E, F corresponding to different nuclei. Consider the four reactions A plus B. So if you are adding A plus B, we already have studied in this region we do fission. Wow, that is rhyming. In this region we do fission, and in this region we do fusion. Why? Because in this region, binding energy is less. We always want something that atom will be more stable, which has more binding energy, because that has released more energy in its formation, and so it is stable. Here, binding energy is less, so it will try to break and come here to become more stable, because here binding energy is more. Done. So here we do fission, here we do fusion. Now let's look at the question more carefully. A, B, C, D, E को आप ध्यान से देखो. So A plus B is happening. Why? A plus B is happening so that it become a C, so that it come in this region and release more energy. That is more binding energy. So here A will be positive. Done. And C is getting converted into A plus B. So for that, energy will be required, because we are going from higher binding energy to lower binding energy. So it's not a naturally favorable thing, and that is why energy will be absorbed. So here E is negative, and here E was positive. D plus E. If we are adding these two and forming F, then again we are moving from higher to lower binding energy, not favorable. Here also negative energy will be required. So negative. F is D plus E. So yes, this molecule is getting broken to form D plus E. Higher binding energy wala molecule ban raha hai. So energy will be released. So energy is positive in case of A, 1 and 4. So answer will be A. Now the Boolean equation for the circuit given in figure is, if you look carefully, this is A, not gate is here. So this will become A naught, that is A ka complement. This is B, this is C. So this is B, this is C. This is OR gate. OR means plus. So this is B plus C. And after that, what we are doing, we are multiplying these two. Sorry, we are like there is AND gate. So on these two inputs, AND gate is operating. AND gate means multiplication वाला concept will come. So A का dot हो रहा है किसके साथ? B plus C के साथ. Dot कहने का मतलब यहाँ पे multiplication. ठीक है. So correct option will be what? D. Just a mathematics. Now a Zener diode having breakdown voltage 15 volt is used in a voltage regulator as shown. The current through the diode is. What will be current through the diode? That we have to calculate. So this is a Zener diode. And Zener diode is a voltage regulator across which voltage remains constant. And here it is, this constant value is 15 volt. So along this, potential difference is 15 volt. So along this also, potential difference will be maintained as 15 volt. So current through 1 kilo ohm, if I calculate I, this will be equal to how much? This will be equal to voltage divided by R, that is 10 to the power 3. So 15 millivolt, milliampere, sorry, current. Now let's do one thing. Current is coming from here, net, isko idea se le lo, I. So here current will divide, right? Some current will go here and some will come here. The current that is going here is how much? It is, but what we need to calculate? Current through the diode. Yes, that we need to calculate. So here it is 15 millivolt. If somehow we know what is the current here, then we can calculate what current will go through the diode. So here, like total voltage is 20 volt. 15 volt is falling here. So rest 5 volt will fall here. So total current, if I calculate 5 volt by 250. So this is 1 by 50. सो दिस इज इक्वल टू, अगर यहाँ पे मैं 1000 लिखूं बाई 50 इंटू 10 to the power 3, तो ये कितना हो जाएगा 20. So 20 milliampere. I is 20 milliampere. So current getting released from the battery is 20 milliampere. Here 20 milliampere is coming. Sorry, millivolt again I have written. Blunder. So here 15 milliampere is going. So here 5 milliampere will go. So correct answer will be what? D. Done. Now let's check with this. In the given figure, which of the diodes are forward biased? So if this is diode, this is p side, this is n side, and inherently what happens, p side पे एक negative charge का layer होता है, and on n side you will get positive charge का layer. Done. So this is happening. In order to do forward bias, p side should be connected to positive terminal of the battery and n side to the negative terminal. Now let's have a look over it. In first case, potential of this side is 0 and potential of this side is, let's say, +5. Done it. Higher than that of 0. So if you look here carefully, p side has a lower voltage than that of n side. So this is reverse bias. P side should be connected to positive terminal, yani ki to the higher voltage side. Done it. Which is not the case over here. So this is reverse bias. Now let's see here. This is connected to +10 and this is connected to +5. So yes, p side to the higher voltage. So this is forward bias. Similarly here, this is 0, this is -10. Again, this is connected to the, p side is connected to lower voltage. है ना? Because this is -10, this is 0. So that is lower. So again, this is reverse bias. If we talk about this is -5 and this is -12. So -5 is greater than -12, forward bias. And here if you see, this is 0 and this is -10. Again, 0 greater than -10. So this is also forward bias. So forward bias कौन सा है? B है, D है and E है. So correct option will be B. Now let's do this. An electromagnetic wave of frequency this passes from vacuum into a dielectric medium with permittivity 4. Done. Then what will happen to wavelength, frequency and all? So permeability, mu is remaining constant. Done. And permittivity is becoming 4 times. So speed of light, if you have learned in electromagnetic wave, then formula is written as 1 by epsilon mu, speed of light ka formula. Done. So if, let's say it is B. So if E is becoming 4 times, mu is remaining constant, it means velocity is becoming what? 2, less than, like it is becoming V by 2. So if initial velocity is this, then final velocity will become V naught by 2. So velocity is getting reduced by half. Now, wavelength and frequency both becomes half. So what happens? It is passing from a dielectric medium with permittivity. This vacuum से इस media में आ रहा है. Done it? So initially it was in vacuum and now it is moving in another media. So what will happen to the light? So velocity is definitely going to become half. Done है? What will happen to the wavelength? We already have studied in our when we were reading what is that called, ray optics, wave optics, Snell's law. There I have proved that when light travels from one media to another media, frequency remains constant. So frequency will remain constant, and frequency is written as what? It is written as V by lambda. So if V is becoming half, then lambda also needs to become half in order to keep frequency constant. So here wavelength is half and frequency remains constant. Option D. Okay. So that is all for this session. And even if you're having more doubts, as I said before in the start, you can ask me in the live classes. Okay? And I hope you all will keep your energy and momentum high, and you will keep attending more number of tests, and also you will keep increasing more number of physics questions that you are attending. All the best, everyone. Stay healthy and safe and keep enjoying and keep reading. Thank you. Bye-bye.